We're going to give you an overview of the vitamin C lab. We're going to be making some calculations on here. We're going to do another titration, but this is going to be a different type of titration. We're looking for a color change in the solutions that we have. So we're going to be counting the number of drops into the solution, and we're going to use that information in order to calculate the mass of ascorbic acid, because we know that concentration here of ascorbic acid. So just by counting the drops and waiting for that endpoint, which is the color change, we can make our calculations that way. So here, let me grab a couple of things to prepare. So this is all background that you can write down and review. We're going to take a look at one of the calculations here. So please make sure that you write this value down somewhere. We're going to need that equation later when we do some calculations regarding our known and unknown. So make sure that you do have that equation available. And they give you a couple samples of how we use that. So here, in order to determine the mass of vitamin C of the unknown, is that we take the mass of vitamin C of our known, which is the ascorbic acid, right? And we multiply by the number of drops from the unknown solution to divide that by the number of drops of the known solution. And that can give us our calculation very easily. So, right. So here's our ascorbic acid mass is equal to the mass in milligrams of the ascorbic acid multiplied by 9 drops of the unknown over 12 drops of the known, and that gives us 9 milligrams. And then we have some more. Because this is just a sample, uh, when we're looking at drinks or fruits, right, is that when we look at that, the sample that we titrate is just a portion of what the entire content is. So we're taking a look at this. They say the lime is cut into 4 equal pieces, and that each squeeze of each piece is 11 milliliters of juice, uh, which means that we have to, which means that we're left with about 1/11th um, of the juice being tested in the titration. So we'll make some adjustments later, but I'll go ahead and show you how to make those adjustments when we have to calculate for like a can of lime juice or a whole entire orange, and we'll make that calculation there. So mass of the reagent here. So here we're just going to simply put this in here, make sure that you tear it out. We're going to grab some ascorbic acid, and it tells us to weigh out 0.3 grams. So please be cautious with this. Do not tap the 1 gram, the 0.gram, 1, 2, 3. And we see that we have about 3 grams there. And I'm going to click it here, record that value. And I now have the mass of my reagent. Now we're going to bring an empty flask in here. I can just grab it. Oh, there's already one over here that I can, well, you know what? That's already down. I'm going to toss out. But this tells me to use, so just make sure that you are reading. We need to add about 100 mils of water here. It doesn't need to be exact, just we got an amount here, 5, 6, 7, 9, and 10. All right, so I have about 100 milliliters in there. And now I'm going to take this, I'm just going to dump it in here. Can toss this away. I put this over here. See when it highlights, as soon as it highlights, I can just let it go, and then it puts it in the proper place. So I don't have to worry about putting it exactly in there. And when we're ready to start the titration, um, this don't quick start stop, because it does take a few seconds. This is going to do a few drops every 3 to 5 seconds. We're going to see a drop. So we're not going to see an initial drop once we hit start. We just have to give it a little time, and you're just going to count the number of drops. So we go here, you'll notice nothing started yet. Don't panic. There it is. There's the first drop. And we're looking for this solution to change color. So it's going to be a color change to something like this. or I think believe that was maybe drop number 5. I'm probably going to pause it 6 and then resume 7. You'll see the color change here, and I'm not going to let you know how many drops that was because that is a calculation that you're going to need to know later. So the drops that were in the standard. And we're just going to go ahead and jump over. Go over here. Is that now we have our standard here. And we're going to need to repeat the process, but this time instead of the ascorbic acid, we're going to be using the lime juice, which means we're going to need to use our pipette. So here it's telling you for the lemon drink, we're using 25 mils. So if you see there, I can put this in here. It's going to drop 25 mils, and then I can go ahead and I can put that into a flask. But I also need to add water to the flask. Or it says add 50 mils of water. So make sure you're adding water to the flask. Then we can put this in here, and you would just simply hold it over here, and you see where it says, "Oh, I need to draw up." I click this button, and it draws up. And then if I move it over here, uh, I have the option to dispense that. I'll go ahead and dispense that right now. 50 mils water, so I'd add 50 here, and it's in the solution here. And you're going to repeat the process here, and you're going to make those count or count the number of drops there. But I do want you to notice here it's asking you that the how much volume of juice is in here. Uh, the volume of juice, right, was 25 mils, and this is what I want you to make note from because when you have to do the orange drink, right, because it's gonna as this is after the titration here. Let me go to the following page. Uh, we do have to change the pipette, right? If I'm gonna put this in here, let me change the tip. I don't, it tells me I need 5 mils, so we can edit this and we can just simply put 5 mils. So now that it draws up 5 mils and I'll have a new flask and I'll put it in there. So make sure that you are aware of that. And then it would be 5 mils of juice that we're putting in there. I'm not going to answer that. Just want to get over to our calculations. So for the calculations, this is a percentage, right? 0.50 weight percent. Okay. So we need that in decimal notation, okay, which is going to be 0.0050, not zero point 0.5, because this is a percentage, which is less than 1%, and that's going to be 0.0050. So whatever the mass is of the ascorbic acid, here's the reagent. This is it, the ascorbic acid. I would take this value here, 0.3034. I would times it by 0.0050, and that would be in grams, but we need milligrams, not grams. So we convert that by multiplying it by 1,000, and that would give us our milligram standard there. So we can answer that question there. um, Now time for the mass of ascorbic acid in the drink, right? Once we know the milligrams here, this is where we're our milligrams here, the number of milligrams in ascorbic acid. Well, the bottle says that this is 0.50 here. We actually don't. Yeah, we just made that calculation here. So the mass of ascorbic acid in the drink. Okay, the mass of ascorbic acid in the drink is we're going to use the milligrams that we calculated here. And this is in this. If you go to page 7, recall those sample calculations. We're going to use this to determine the milligrams in the of acid in the lemon lime drink. Okay, so whatever the mass of acid is here, that's this value. We're going to multiply by the number of drops we used in the standard. I'm sorry, the multiply by the unknown. So however many drops of your unknown divided by the drops of your known, which is the standard. So again, we're going to take the mass that we just calculated, multiply it by the drops of the unknown, lemon lime juice drink, divide that by the number of drops of known that we use for the standard, and that will give you its mass in milligrams. And then we're going to repeat that same process for the mass of acid in the orange juice, right? So this is the lemon lime juice. This is the orange juice. So again, we are still going to use the mass that we have here for the ascorbic acid, multiplied it by the number of drops for the unknown, divided by the drops of the known that was used for the standard. We'll have another uh, calculation made there. Now, as far as if this were a folder, because again, we talked about this a little while ago, where this isn't the whole entire can of juice. This is just a small sample. So normally we get 440 milliliters for this soft drink here, but we use 25 milliliters. Okay. So what it's asking for on this page for the discussion, the mass of ascorbic acid for a full can. Well, if we know how many milligrams that there are for the drink, we can take that mass, multiply it by 440, divide it by 25, and then we get the mass for the full size drink. And then for the orange, now I'm not going to answer that. I'm going to move to the next page. Now for an entire orange, right? They don't give you that ratio. In the previous page, 18, they gave you the ratio times by 440, divide by 25. Here they want you to figure that out, but I'm going to give you a little help. It says for the third trial, they cut up an orange in 9 sections, and each section had 9 or 10 milliliters of juice. So we're simply just going to take the 9 sections, times it by 10. That's 90 milliliters of juice for an entire lemon. Well, we used 5 milliliters of that juice. So you're going to take the mass of ascorbic acid, times it by 9, divided by 5, and that are going to be the milligrams for the entire orange. And now we have to calculate some errors. So the error is simply calculated here. I'm going to highlight it for you, and this is how we need to calculate the error. And just round it to one significant figure. You're going to take the number of 1, right? 1 divided by the number of drops, and then multiply by 100. Right? Uh, that's how they calculate. See, we see that same calculation. 1 divided by, let's say, 11 drops were used. That's going to be 9%. Those 20 drops, 1 divided by 20, multiplied by 100. It's going to be 5%. So that's how you, in the DHP for the standard here, 1 divided by how many drops you used, multiply that by 100, and then round it to one significant figure. And you'll do that for each one of these here to calculate all those errors. Then we get to our discussion questions. And we talk about error. So uh, the more drops that are used, that lowers the error, right? We've seen that in the previous slide where we talked about those errors. So if something used less, fewer drops, right? That is less reliable by using less drops. Excuse me. Um, Now notice we didn't use the volume of the DCP. We just counted the number of drops. So as long as the volume of the drops don't vary, right? But the volume of the drops isn't needed as long as the drops themselves don't vary much. So as long as they don't vary, we're good. And notice how we used more 25 milliliters of the lemon lime juice versus 5 milliliters of the orange juice. But if we had used 5 mils of each, this would have required less drops, which means we would have had a larger error, right? So with 5 milliliters of drink, too much of this would be used. Um, let's see, There it is. So with 5 mL drink, the number of drops for the react would have been a really small number, and that would have gave us a bigger error, and we don't want that. And then finally, here, if you'd been to look very close in each drop, when you're doing this live, if you take a look at this, we do a titration in the lab, and when a drop hits the solution, there's a little pink swirl that usually happens and then disappears, because in the immediate area where that drop hits, and at that moment, uh, the reaction takes place. But as you're stirring it, we get excess, which then kind of removes that color. So here it just a really small region where it hits the solution first is where we get that small reaction. So if you had been able to see this live, you would have been able to see that swirl that I talked about. And that should be it for the lab here for vitamin C.